Yeah, there's a whole week in there. That's what I say. It's like I'm too far ahead. I need to slow myself down. So we're only covering one section a night, and that doesn't mean I'll leave early. If you need help to prepare for the test on Tuesday, use that time to your advantage. If you come in desperate on Tuesday, I won't care at that point. If you desperately email me on weekend, I won't care at that point. But use this time. Okay, so today's 11.2. Is it 1103? Yeah. 1103 would be the chapter 10 test. You can have 3 pages of notes, front and back. Whatever you want. 1105. Let's see, if we do 11.3 that day, boy, that's still a short class. 11.10, 11.4, and then 11.12, chapter 11 test. I mean, we could cover topics out of Calc 3 if you wanted. Some of the tests have been pretty bad in some of the past tests, so I thought, because I really thought about pushing ahead because I hate finishing up early because I get bored. Let's see, 11:17. I guess the makeup test day. 11:19, answer questions day. I won't have anything for 11:19. I'll just come in, sit here, and answer any questions you have. So, then the 24th is the final exam. You got a whole weekend to prepare for it. You're in good shape. I'll put this up each time. If we have to alter it, you never know. There might be snowstorms, ice storms. But I'll bring this up each time, so at some point everybody will have seen it, and not be caught unaware. Okay. So section 11.2, space coordinates and vectors in space.
Would we leave off on? Would we leave off on?
We finished 11.1.
I know, but what was
the last topic? I don't remember. Looking right at there it is. This is on page 762, and shows you coming out this way is your x-axis, this way is your y-axis, this way is your z-axis, maybe. The important part is you see z going up. You'll find that you can rotate this depending upon your software package. So you can't always say the line coming toward you is the x. It all depends on how it's been rotated. Here's points here. And so when you're plotting a point, like this one's -2, 5, 4, it's x, y, z. And you see this is x here, so it goes back -2. And then y is 5, so it goes the distance of 5 this way. and then up 4. Then up puts a point. Now there's different coordinate systems. They talk about some of these here. The right-handed system, left-handed system. It'd be nice if there was a universal standard on everything. Here's a package called Blender. You can see Z's up and X is along here and Y is along here, but you can change them. So different packages have it set up so you can go different ways. Couldn't tell you about AutoCAD or SolidWorks. Is that the other one that's kind of a design package? But you get used to it when you start working with it.
What would we use?
For what?
Which way would our team?
For this class? X would be this way, and Y would be this way, and Z would be this way, unless you rotate it. I won't ask you it on the test. So, yeah, this is the official 3D package that Butler uses. So if you go on Calc 3, this is the one the math department puts out there. So this isn't one I found. This is the one they put out there. It's a really good one. The one I was using before this was horrible. I don't even know if I still have that. Peanut Softwares. Peanut. Yeah, I still got Peanut. WinPlot. And it's just hard to use. It's just a horrible package. I didn't even know how to do 3D. Let me see. 3 dimensions. It's been so long. Let's see. Let's see how the axis disappeared. Has plenty of things like that happen. And they took this off their website. College had built this, and I don't know why they took it off, but maybe they fired the professor who came up with it. I don't know. And they're afraid of getting sued, or tired of support. So yeah, the one that Butler chose is a pretty good package, and we'll learn how to use this. I put a link out there in Canvas. Yeah, it's first entry here down in Unit 12, so CalcPlot 3D. So definitely want to say that. I'm sure they'll use it in whatever class you go to. If you have T89, that graphs in 3D. A TI-92, I think, graphs in 3D also. But Butler's taking the position that they're not going to require graphing calculators. So there is so many people use this one. Or T89? I don't know if I ever paid for mine. So, I don't know. Yeah, as an instructor, I get those calculators for free. Just as long as we have it on our syllabus requiring a calculator, then Texas Instruments will give a college so many calculators each year. And I don't remember what the last one I got was TI-92 or TI Voyage. TI Voyage. It's still sitting home. I never have used it. It's just like free. So. And it doesn't seem right to sell it on eBay, just something you get for free. So. I actually got a nice calculator from Larry Friesen here at college. It's like me, he gets these free ones and says, I haven't used this. Do you want it? And I say, yeah, I'll take that. I never have plugged it in to even charge it up. Okay. I'm not very good at this. So I'll do one of them and then we'll go over to the package.
Yeah.
How much?
It's like 185. Oh wait, no. Carter has it for 130.
T89 is kind of the old one, but a lot of people like it. These websites are nice, but you have to have access to the internet, right? If you can't use your cell phone during a test, then what good does that even use you or do you? Okay, I'm going to graph 213. Well, some instructors won't even let you use it. So it will do almost all the problems in Calc 1. You just type them in, it gives you the answer. It's called Computer CAS, Computer Algebra System, I think is what it stands for. And those kind of calculators usually are banned. TI Voyage is one of them. TI-89, TI-92. I think Casio has one. HP Prime, I think is maybe. Pretend this looks 3D to you.
Which problem is this?
5A. Yeah. Okay, so this is our X. As you go this way, it's positive. As you go this way, it's negative. This is our Y. As you go this way, it's positive. As you go this way, it's negative. And this axis is our Z, and as you go up, it's positive. And as you go down, it's negative. Maybe. Pretty soon you get used to not thinking these in absolutes. I don't. I might have AutoCAD actually loaded on here. Callie panicked me. They were asking me if I knew if I had taught AutoCAD before. I said, yeah, I taught it a couple of years. And then I was thinking they're going to ask me right away to teach it. So I better start getting my knowledge back up. I installed it. That's about it. Z is going up, but now going up, Z is still going up, but it's negative up there. Yeah, the positive is now going down. So this is what you find in all these design packages. You can rotate them however way you want. So don't think like up is always positive and down is always negative. It's always relative to what you're working with. But that's the way it is at default. Okay, so X is 2. So I've got 2 units there. Y is 1, so I've got 1 unit there. And they intersect right here. And my Z is 3. So that means I go up 3 units. If you look at this distance here, from this point, you go up that distance, which would maybe be about right there. That's as good as I'm going to get. Now this one right here, by default, it comes up with this. You can reset this package by clicking these 2 little arrows here. So if you graph something, you want to set it back to the standard, then that takes you back there. It comes up with that as default, I suppose, just to catch people's eye. You can delete that by clicking this X over here to the right. And now get rid of it. Clear the plot. Here's a zoom in. Here's a zoom out. Toggle 3D mode. I don't remember what this does. Looks 3D maybe? I don't know. Yeah. Toggle transparency. I don't see any difference. Must have to have a graph in order for that to work. And I have no clue what E is. I never use it. No, toggle edges. Some of these only work if you have a 3D graph. Like toggle faces, that fills in the faces. You got these lines up here. You know, the help manual, scripts. I didn't know you could write scripts. Do settings here. See examples if you're trying to figure out how to do something. Now add the graph. Let me reset this. There we go. Add the graph. You see there's one specific says point. So I choose that. And I'm graphing 213. Four isn't very big, if I remember right. So let me change that to 6. Press enter. Now 213. See how this stopped at 2. Yeah. Still doesn't quite look like what we had, but you know, if you rotate it, I'm holding down my mouse wheel. And I have a hard time rotating this package. I do better if I use my arrow keys, because then it's very precise. I start moving that mouse and it starts rotating the wrong way and so forth. So I'm using my left arrow key and right arrow key to go like that. You can use your up arrow key and down arrow key to rotate in that manner. Let me do one more. I think you have that. -1, 2, 1. So I can add the graph a point. -1, 2, 1. And that'd be that graph. Boy, I really messed that up. I'm never going to get that back. Anyway, you see that plot point. Quit rotating with the mouse. Any questions on plotting points like that? Obviously, I'm not going to ask that on test because you don't have a laptop computer in front of you. So these things I'm showing you here are just for your benefit going on to other classes. Now this one I thought was just kind of weird, but maybe it's worthwhile. It says, determine the location of a point XYZ that satisfies these conditions. I mean, this would be so easy I couldn't put it on the test. If I look at 14, y is equal to 6. Remember your T-charts? I tell you what, you get really desperate if you start plotting points in 3D. I did that in Calc 3 way back when I was 20. You know you're desperate when you do that. Imagine trying to plot a 3D shape by plotting points. Yeah, 2 months maybe, and you'd have your graph. But when you're sitting there blank and you want to put something down, you start doing things like that. Okay, what can I choose for x and z, do you think?
0.
Okay. What does y have to be? 6. So valid point there is 6, 0, 6, 0. You can put anything in for x and z. This is actually a plane if we were to graph it. I'm going to go ahead and graph it just to demonstrate that. Now over here, there's the z equals. That's where you got to solve for z. There's an implicit surface. What? Oh, you could. Implicit is where it doesn't matter what form it's in. This is the one I like. So here, y is equal to 6. I just type y equals 6. And y should go from probably negative or 0 to -1 to 7. X, that's probably fine. Yeah, how do I get to change? Maybe I don't know how to do that. I thought Enter did it, but I don't see it changing. Yeah, there it is. So zoom out one time, I guess, would get it to appear. That's weird that these, unless I should fill those in before I put my equation. I don't know. Now it looks like it just stops, but this doesn't. It goes infinite directions everywhere. It just stops there because I got these set in this manner. It still doesn't look like. Okay, set your window settings before you do it. Okay, I'll learn how to use Packet someday. This is a blessing, by the way. I barely got through Calc 3 back in the early 90s. Hardest course I ever took in my entire life. Have you ever seen that old Star Trek, Wrath of Khan? Nobody seen that? Oh, you haven't seen it? Well, Spock is telling Captain Kirk that Khan, he has an advantage over Khan with the superior mind and all this and that. He says he thinks two-dimensionally. Well, that's why I do. I think two-dimensionally. So if you ask me to graph something by hand, I'm not very good at it. These tools have made it so much easier. You can visualize it. You can see what's happening. You can rotate it. Okay. 20 might be interesting. Absolute value of x is greater than 4. Now, ignoring my other two variables, we got our absolute value of something is greater than 4. What would this become? It's a formula from college algebra. Let me write down the formula. This is P and this is Q. You rewrite it as P is less than negative Q. There's an or between them. And P is greater than positive Q. So if we were to plug it in, x can be less than negative 4, or x can be greater than positive 4. So if I were to think about like a, whatever this would be called, clothesline chart, not a T-chart anymore. How about y and z? What can they be? Anything. But x either has to be less than -4 or it has to be greater than a +4. So like, for example, 5 would work. Now let's see what this looks like, because I'm curious. Implicit surface. I'm assuming absolute value is probably ABS. X. And there's an error in the implicit equation. Don't like absolute values. Oh, it's inequality. I've ever tried doing inequality. Why are you doing inequality? I don't think it'll allow you doing inequality. What would that graph look like? It would have an empty slice in the middle. What kind of shape would, though it's impossible to say because it's going infinite, but yeah, kind of squarish, rectangular in the middle, right? And then on the other sides, it's going forever, isn't it? On the x, and y and z are going forever in their direction too. Let's look at 24 just for kicks. XYZ is greater than 0.
That x times y times z is greater than 0, or that x is greater than 0, y is greater than 0?
No, it's x times y times z is greater than 0. I have no clue what this graph would look like. Like I say, I think two-dimensionally. If you're going to be an engineer, I suppose if you design three-dimensional things, you better be good at thinking three-dimensionally.
That would go anywhere. Well, the thing is, they could be positive or negative. If you have all three negative, it's going to not negative. There are going to be two negatives, not positive. So, any which way, I think it's going to go anywhere.
Well, it can't all be negative, which means that it's one of the octants is gone then. Because when you're talking about
Yeah, it's greater than 0. So you can have three negatives, but you can't have two negatives.
yeah, so I can't draw it, but in the back down, that octant can't exist because it can't all be negatives.
Yeah.
So I know it doesn't exist there. I guess about anywhere else it could exist. Yeah.
But wait, no, if you have one negative, it can't be in that section. So that gets rid of.
Oh yeah, because if it's one that you're right, and one negative, if it was over here, for example, this being negative, positive, and positive, that isn't possible either. Then it can't be possible down here either, because this is negative, positive, positive. Anyway, they just want a point. But if I chose like 3, 2, and 1, that satisfies it. So, like I said, they're not very challenging problems on that. They wouldn't like the inequality. Oh, CalChat.
Yeah.
All they want is a point. It probably says answer varies. I've had people turn that into their work. Yeah, I think I may have called him an idiot in class. Not directly. I just said, if you just turned in work that says answer varies, you're an idiot. You just copy straight off the key. At least change it. It's like recognize what it means when you say answer varies. Yeah, people are funny. They get desperate. Here's the distance formula. Looks familiar? Yeah, x2 minus x1 squared, y2 minus y1 squared. We got something additional in the square root. z2 minus z1 squared. So if you're trying to find distance between 2 points in 3 dimensions, then this is the formula you use. I had a student that did. I called him an idiot when he wasn't there, and he came in this class. Did you really call me an idiot? I said, yeah, I called you an idiot. You're an idiot. Or he did something idiotic. I forget what I said. He meant to text his best friend. He texted me something about calling me a D head, and and it was a very humorous text. I've actually kept it. Yeah, I said that's the most stupidest thing to do, to text your instructor and call him a D head. So I didn't hold it against him. I just thought it was funny, but I did call him an idiot. It was an idiotic move. Yeah, there's no other way to put it when you text your instructor and call him a bad name, meaning to text your friend. No, I didn't. Everybody screws up, but if you do something that is an idiot, you should accept the term. It wasn't even just calling me that. It was like, tell the D head that I'm sick, or it's like I'm reading this text and stuff. Okay, find distance between the points. Okay, so we're going to use these. This is our first point, so I just label that as x1, y1, z1. This is my second point, so I label it as x2, y2, z2. Doesn't matter which one you actually label as your first point, which one's your second point, it still works. So square root, we subtract our x's. 8 minus 4 squared plus 2 minus 1 squared plus 6 minus 5 squared. 8 minus 4 is 4, so we got 4 squared, plus 2 minus 1 is 1, so we got 1 squared. 6 minus 5 is 1, so we got 1 squared. 4 squared is 16, 1 squared is 1, plus another 1 is 18. And yeah. I expect most of your classes that you go into, they'll want the exact answer like this. Then you'll enter out in the workforce and they'll just want the decimals. So because decimals makes more sense when you're designing something. Yeah. Now we got a sphere, and just like when we had a standard form for the circle, we got a standard form for the sphere. And with the center at x naught, y naught, z naught, and radius r, Then our standard form is x minus x naught squared plus y minus y naught squared plus z minus z naught squared equals r squared. Means different things, but it can mean initial. Oftentimes does. In this case, it means the center, which there is no real initial point on these. And then your midpoint formula is the order triple x1 plus x2 divided by 2, y1 plus y2 divided by 2, z1 plus z2 divided by 2. These problems are a little bit more interesting. Well, not the midpoint, but the equation of the sphere is. You'll find a lot of things in life are based upon very basic shapes. It's not like you got 100 basic shapes you work with. So people look at this like, well, how can they focus so much on these? Not everything in life follows these. But the design tools, like here, add mesh, plane, cube, circle, UV sphere, icosphere, that's a bit different, cylinder, cone, torus, monkey. That's their mascot in Blender. But there's very basic shapes. And from those basic shapes, you can apply different modifiers and so forth, so you can create anything. So if it looks like you're taking Calc 3 and they seem just focused on certain shapes, well, that's because a lot of things you look at are based upon basic shapes. They kind of got fancy here with a design like that, but circle, circular, you look at it from these different angles and circles and so forth. What?
iPhone 12.
Was it?
The iPhone 12. That looks like a brick.
Oh, does it look like a brick? I haven't even looked at it. Okay, so let's take a look at number 33. So they selling it now? See, well, I wouldn't buy one of those because I'm too cheap anyway. But I sure wouldn't buy one right now. Being banned, Trump winning and deciding that China's using that to spy on all of us. And all of a sudden, those are banned from use. 20. Mm-hmm. Okay. Now the instructions here say to find the midpoint. Midpoint's very easy. Add to x's divided by 2, add to y's divided by 2, add to z's divided by 2. 4 plus 8 divided by 2, 0 plus 8 divided by 2, negative 6 plus 20 divided by 2. 4 plus 8 is 12, divided by 2 is 6. 0 plus 8 is 8, divided by 2 is 4. Negative 6 plus 20 is 14, divided by 2 is 7. And that would be our midpoint. These are probably the only interesting one of this section, I think. Find the equation of the sphere. And we'll look at 45. Nine x squared plus 9y squared plus 9z squared minus 6x plus 18y plus 1 equals 0. It says write it in standard form, find the center and radius. Now what makes this a sphere is the fact that there's 9's in front of all three variables. The x squared, so I should say, the y squared and z squareds. If there's a different number in front of these, it wouldn't be a sphere. It might be an ellipsoid object of some sort. I bet I can actually graph this. Nine x squared plus 9y squared plus 9z squared minus 6x plus 18y plus 1 equals 0. And that shows our graph. Didn't know what the radius would be, so I didn't know if this was enough, -2 to 2, but I guess it is. Okay, so to get this into our standard form, what we're going to do is we're going to group the x's together. So 9x squared minus 6x. We're going to group the y's together. 9y squared plus 18y. Group the z's together. 9z squared. That's the only one we have there. And we'll take the number over to the other side. Now, we don't want the number in front of the x squared, y squared, and z squared. And since this is a sphere, we can divide everything by 9. So that's going to give us x squared minus 6 9ths x plus y squared plus 2y plus z squared is equal to -1/9. So x squared minus, that simplifies, 2/3 x plus y squared plus 2y plus z squared equals -1/9. Now we want to complete the square to get these in the right form. So for the x's, I'm going to take the number that's in front of our x, which is -2/3, multiplied by a half and squared. That gives us 2's cancel, -1/3 squared, or 1/9. Now we're going to add it to the x group, and we'll also add it to the right side. We also want to do the y's. So we take the number of 4y, which is 2. We multiply it times a half and square it. 2 times a half is 1, and 1 squared gives us 1. And we'll add that to the y group. And I'll also add it to the y group over here. Or add it to the group over here. Z squared I'll come back to. Now this factors as x minus 1/3 squared. This one factors as y plus 1 squared. The z I can rewrite as z minus 0 or z plus 0 squared. And negative 1/9 plus 1/9 cancels and gives us 1. Remember the trick for completing the square on those? Whatever number is right here, right before you square it, sign included is always what goes right here. And you want this as z minus or plus something. Now this would be, let's see what letters I use. HK, I'm assuming, but let's see. Nope, I use an x naught, y naught, z naught. This will be x naught. And it's always the opposite sign. So I'll be a positive 1/3. This will be y naught. It's always opposite sign, so it's negative 1. And this will be z naught, which is 0. If you're wondering why the opposite sign, in my formula I have minuses, negatives. Whenever you have a minus or negative in your formula, that's what flips signs. So my center is going to be 1/3, negative 1, 0. And my radius, we take the square root of this, so which is just 1. See, this would be a good one for a test. Something a little bit more interesting than plotting points. If I get desperate, I might put midpoint and distance on there. I hate to put something you get so offended you throw it back in my face. So give me something challenging. Yeah. Now vectors in space. This just extends what we saw last time into 3 dimensions. So nothing exciting on them. Component form. See how it's now Q1 minus P1, Q2 minus P2, and Q3 minus P3. The Q1 and P1 are just your X values. This is your Y values, that's your Z values. So what we saw last time, but add a Z on at the end. The magnitude, the length, we just put another one on the end for Z. The unit vector, well that formula didn't even change, did it? It's kind of weird they got V there, but the unit vector is usually like U in the formulas, but it's V over the magnitude of V. Hadn't changed. Vector addition, just like before, you add X's, add to Y's, add to Z's. And scalar multiplication, just like before, multiply whatever number's in front times everything inside. Okay, let's take a look at number 47. This one?
I was talking about this line.
Oh. Okay, so 47. We're going to have our initial point, which is 421. And we'll have our terminal point, which is 2, 4, 3. Just like vectors in 2 dimensions, vectors in 3 dimensions have a little arrow indicating the direction, so you can see which one's your initial and which one's your terminal. Now it says to find the component form of the vector v. So this is my x's here, like x1, x, y, y1, z1, x2, y2, z2. Then our, what do they tell us label it as? Vector v. We're going to subtract our x's, specifically terminal minus initial. So that's x2 minus x1, y2 minus y1, z2 minus z1. So we'll have 2 minus 4. We'll have 4 minus 2, and we'll have 3 minus 1, which gives us negative 2, 2, and 2. Now we got some unit vectors. Here's one of them, 1, 0, 0. This is represented by I. We have 0, 1, 0. This is represented by J. And we have 0, 0, 1, which is represented by K. Now I could split this up like I showed you last time, but it really is just the easiest what I showed you shortcut wise. Is this is you just put an I on it, so negative 2I. This you put a J on, so plus 2J. And this one we put a K on. That is another way to represent our vectors. And they say to graph it, coming from the origin, I believe. Sketch a vector with its initial point at the origin. If you got the component form, I think this does it over here. Let's see. Vector ABC. Should we reset that? So this is negative 2, 2, 2. I don't think so, unless I wrote my numbers down wrong. 3 minus 1 is 2. And you see how your vector is going out like that. Again, very easy to graph, to visualize in this package. No, because we'd have to have computers in this room. Okay. That's another one like that. I think you've seen enough with one. Don't really do much with this in this section, but definition of parallel vectors. two non-zero vectors u and v are parallel when there's some scalar c such that u is equal to c. The vector u is equal to the scalar c times the vector v. And there might be some problems dealing with that. In 2 dimensions, what that would look like is this example. It's very easy to come up with examples. Assuming I can do basic math. I think that's right. Those would be parallel. Because on this one, I could factor a 3 out of it. Like this. And see how this vector here matches this vector here, doesn't it? That's what they're referring to when they say there's some scalar c such that that's true. So I don't know much about these, but I know they're parallel. I think there's some problems on the 3 dimensions, so I won't make one of those up, even though they're not hard. Okay. It says find each scalar multiple of v and sketch its graph. If you want to sketch it on that, I would actually recommend sketching it to get used to using that tool. Let's take a look at 57, at least a couple of them. Look at that one and C, I guess. 3/2 v. Well, when you got scalar multiplication, you just put the number out in front of the vector like this. And it's just like the distributive property. You take the 2 and multiply it through. So it's going to give us 2, 4, and 4. The reason why they're putting this right after the definition of parallel is because these are parallel, aren't they? Now here, you put the 3/2 out in front. And distributive property, I'll multiply through, and that gives us 3/2, 3, 3. And that's how you do scalar multiplication. Actually, all these, I guess, would be good for a test. Let's take a look at number 59. And we got U, 1, 2, 3, V, 2, 2, -1, W is 4, 0, -4. Z is equal to U minus V plus W. So we're trying to find the vector Z. So on this, you just plug those in. If you prefer to have the I, J, and K, it's probably a little bit easier even. That would be 1I plus 2J plus 3K minus V, which is 2I plus 2j minus k plus w, which is going to be 4i. The 0 would drop away, minus 4k. Then you treat them just like variables. So I got I plus 2j plus 3k. Negative out in front flips the sign of everything inside. So I got minus 2i minus 2j plus k plus 4i minus 4k. Let's see, I minus 2i is negative I, plus 4i is 3i. 2j minus 2j, that cancels. And there's no other j's? It's not. 3k plus 1k is 4k minus 4k. Assuming I added everything correctly, then our answer is 3i. Now, I'm going to show you how to do the setup on 61, but I won't actually finish it. The only interesting part is the setup. I want to find a vector z, so I want to solve for z. Well, we got a minus u. Well, I'm getting sloppy about those. What do you think I'd do first to get rid of that minus 3u, the negative 3u? Yeah, add 3u to both sides. Those would cancel then. And so I got 1/3 z equals w plus 3u. Now what do you think I'd do? Yeah, multiply both sides by 3. Get z, and I could carry that through, like the distributive property. So 3w plus 9u. Now plug in your w and u and simplify it, and you get your z. Now addition and subtraction work well that way. Scalar multiplication works well that way. When you're talking about multiplying and dividing, it doesn't work as well that way. But they don't even introduce that concept here. Let's take a look at number 63. This is asking us to identify parallel vectors. Yeah, I've never called a student stupid because of lack of knowledge, because everybody's at the same place where you're just learning. But I have called students stupid because of what they did sometimes. I had somebody here at Butler one time cheated on a test, and then they argued with me about it that they didn't cheat. And worse, he approached me to be if he could get a recommendation for me to be a tutor. Yeah, he crossed some real thresholds there. I'm pretty easygoing, and this was Calc 1. And he came to class, told me he was feeling sick, and asked if he could take it in the testing center. I said, yeah, that's no problem. What he didn't realize is I had two versions of the test, and I put like version A in the testing center for him. Well, all of his work was version B. And it was stapled right to version A, and I gave him a 0 on the test. Boy, he argued with me to his blue in the face. He did not cheat on that test. I said, unless you're a psychic, there's no way you could have known the problems on the other version. Okay. Now this is 3. I would need this to be 3. What number could I factor out of this to make that a 3? Almost -2. Well, of course, I'd have to factor it out all of them, right? So if I factor a -2 out of that, that gives me a +2. Factor a -2 out of that, gives me a -5. Does this equal my original vector? Yeah. So these are parallel. This one's a little bit more challenging. You almost have to think of it going backwards. I need to factor something out so that this is a 3. 2/3? 3/2. I'm glad you guys said 3/2. I was drawing a blank. But if you think of it going the other direction, the 2's would cancel and you'd be left with a 3, wouldn't you? No, you're right, 2/3. Because what do we need here? We need a 3. Okay, let me think about that. Would 2/3 work? Yeah, you're right, 2/3. Yeah, if it's going backwards, now if I multiply those 3's would cancel, I'd be left with a 2, which is my original. But now I have a 3 here. Now, factor means to divide out. So if I took 4/3 divided by 2/3, 4/3 times 3/2, 2. If I took -10/3 divided by 2/3, I should be able to do this in my head, but it's been a long day. -5. Does this equal my original vector? It does, doesn't it? Which means, yes, these are parallel. You could almost think of it as you're asking yourself, what times 3 gives you 2? 3 times something gives you 2. That's where 2/3 comes from. So if I did the same type of concept down here, what times 3? Well, that's pretty easy, isn't it? What would I have to factor out here? 2. Yeah, because the 5 is screwed up, isn't it? So the answer on this is no, these are not parallel. This vector, it had to be the same as my original vector. Okay, so now I can use a little trick here. I asked myself, what times 3 would give me a 1? And that'd be 1/3. So that means I factor 1/3 out. Again, factor means to divide out. So let me think about this. So I have my original number divided by 1/3. That gives me a -12. And right away I can stop, right? Yeah, who knows? Yeah, maybe it'll straighten itself out. What's the next one? 2 divided by 1/3 gives us 6. Yeah. Doesn't work. Those would be good ones for a test. If I could make this chapter any harder, I would, but there's just no. All of them are pretty easy. Cross products is probably one one's a little bit weird, but not if you remember your college algebra. Remember determinants, 3 by 3, cofactor method. That's okay. We're going to review it. Most people have forgotten it completely anyway. So. Find the magnitude. Again, these would be good ones. 73 looks too easy. Let's leave 77. I minus 2j minus 3k. So our magnitude, or our length of it, is going to be the square root, and you take each number in front of the I, j, and k and square it. So 1 squared, negative 2 squared, and negative 3 squared, and add them together. So 1 plus 4 plus 9, square root of 14. Okay, last problem. Number 83. Magnitude of V is equal to 10. And it's in the direction of U equals 0, 3, 3. And it says find a vector V with the given magnitude and same direction as U. Well, we have to find our unit vector. We had a formula for that. Our unit vector would be our vector over the magnitude. This gives us a base vector that we can work with. We then can apply the magnitude towards. Now, where I got that from? Where did I get it from? Right here. Our unit vector in the direction of V. So just the vector over its magnitude. So, on this one, I'm going to have 0, 3, 3, then the magnitude, square root of 0 squared plus 3 squared plus 3 squared. 0, 3, 3. 0 squared 0, 3 squared is 9, 3 squared is 9, that's square root of 18. Now, that simplifies. 18 is 3 times 2, 3 times 2, 9 times 2, 3 times square root of 2. Then I'll put each one of those over 3 square root of 2. So that gives us 0. 3's cancel here. I have 1 over square root of 2, multiply top and bottom by square root of 2. So square root of 2 over 2. Here the trees cancel. I got 1 over square root of 2, multiply top and bottom by square root of 2, and you got square root of 2 over 2. Now this is such that if you were to use the distance formula on this would give you a magnitude or length of 1. So that's why it's called a unit vector. But we're wanting to find one with this magnitude. So what we do is we take that times our unit vector. Zero, 5 square root of 2, and 5 square root of 2. And that'd be our answer. Well, that's the end of that section. So I'll go ahead and stop the video. If you got questions on anything, stick around. I'll help you figure out, what part you're not understanding. But otherwise, we'll have the test next class. You get the entire class for it. 3 pages of notes, front and back again. Let me kind of read off what's going to be on it.